أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Wireless communication systems are vulnerable to interferences from noise, which can be defined as undesirable or random shifts. As a result, the communication system overall performance may severely suffer, data transmission accuracy may suffer, and maybe the received signal quality is not up to the mark so that we can recover the noise. Noise can be generated by many reasons and it depends on many known and unknown factors. In today's unit, we firstly define the types of the noise, what is noise itself, and how they originate. And then we discuss about why noise is important for wireless communication system. And then we little discuss about man-made noise, and then mostly we discuss about the internal noise in communities. Wireless communication noise, which is unwanted signal, can be originate from various sources, including natural sources, electronic component, and external threat. Some common source of noise in wireless communication system can be classified as natural sources, man-made sources, or fundamental sources. In wireless communication, there are several ways where, where noise is generated by naturally available resources that can affect the quality of the received signal. It is important to note that natural resources of noise are inherent to the environment. We cannot eliminate 100% from the wireless communication system. So their impact on the wireless communication system can vary depending on the available natural factors such as frequency band, geographical location, and atmospheric condition, temperature, snowfall, and many other natural sources. Some are most common natural sources of noise are thermal noise, also known as Johnson-Nyquist noise. It is caused by the random motion of the electron in conductor due to thermal energy. Similarly, cosmic microwave background. So cosmic microwave background is a faint radiation that permeates the universe. It is a remnant of Big Bang and appears as a uniform noise-like signal all over the entire electromagnetic spectrum, including radio frequencies also. The cosmic contribution to the background noise in wireless communication systems can be very serious effects sometimes. It depends on the environment. But atmospheric noise is another natural source which introduces noise into the wireless communication system. For example, lightning discharge produces a background radio frequency noise like atmospheric noise or atmospheric static. This noise can be particularly significant in lower frequency band. And similarly, the solar noise so sun emits large radio waves across a wide range of frequencies. So solar noise can be caused by solar flares, spots, and other solar activities. It can affect wireless communication systems, especially those operating in very high frequency bands. Similarly, terrestrial noise also refers to the noise generated by natural resources such as Earth. It includes noise from lightning, thunderstorm, uh, atmospheric disturbances, and electromagnetic interferences caused by geological features such as electrical discharge from the log, and other such activities. Electromagnetic interferences, EMI, can arise from the natural sources such as lightning and storming. These sources generate electromagnetic fields that can interfere with the wireless communication system. There are few examples of natural noise, but many other noise are also which are we are not discussing. Study of noise is very crucial for wireless communication system for many reasons. One of the most important reason is signal quality. Many people that signal can degrade the quality of the wireless received signal. They introduce many random variation and distributions that interfere with the desired signal and leading to the error and reduced signal quality. By understanding and analyzing noise, the engineer can design communication systems that can control its impact and improve signal quality. Similarly, signal to noise ratio is a fundamental parameter in wireless communication, which represents the behavior of the noise in a given channel. It represents the ratio of the power of the signal of interest to the power of the background noise. The higher SNR generally leads to the better communication performance. By studying the noise characteristics, an engineer can optimize the system parameters and techniques such that can lead to the improved SNR and overall improved system performance. Similarly, noise also affects the channel of a wireless communication, which ultimately disrupts the maximum data rate and that can be reliably transmitted over a given channel. So, in other words, noise limits the achievable capacity, has introduced error and reduces the available signal power. By understanding the noise properties, the designer can develop coding and modulation schemes that can mitigate the effect of the noise and increase the channel capacity overall. Similarly, noise can also arise from external sources, such as other wireless devices operating in the same frequency band. These interferences can disrupt wireless communication and sometimes completely degrade the system performance. By studying noise sources and interference pattern, engineer or designer can lead to such design systems that minimize the impact of interferences and improve the overall communication, highly reliable system with a highly reliable. Similarly, noise characterization also play a crucial role in designing of wireless communication systems. And sometimes designers need to consider noise parameters such as noise figure, noise temperature, and noise power spectral density, which designers used to design the transmitter, receiver, and antennas in order to improve the overall behavior of the wireless communication channel. The most important, sometimes it is most important, is regulatory compliance. Noise levels are regulated by government bodies to ensure that sufficient spectrum is utilized and minimum interferences between allocated wireless channel with devices. By studying noise characteristics and their impact on the communication system, engineers can contribute to develop of such standards and regulations that can govern wireless communication and ensure proper coexistence of the device. Finally, we can say that studying noise in wireless communication system is very vital for optimizing system performance, achieving higher data rates, improving signal quality, reducing interferences, and complying with regulatory requirements. Enables engineers to design robust and efficient wireless communication systems that can operate highly reliably in various environments. Similarly, man-made noise, referred as unwanted signal or interference, generated by human deliberate or non-deliberate activities that can disrupt the wireless communication system. Here are some common sources of man-made noise, such as electromagnetic interferences. EMI is caused by the unintentional emission of electromagnetic energy from various electrical and electronic devices which are developed by humans. Example include power lines, electrical motors, fluorescent light, electronic equipment like computers, television, mobile, iPad, different type of electronic gadgets. EMI can interfere with the wireless communication system, leading to degrade its signal quality and performance more directly than as a device. Similarly, RFI, radio frequency interferences, occurs when undesired radio signals are introduced into the communication environment. It can be caused by the device, such as a microwave oven, cordless phone, Wi-Fi routers, switches, Bluetooth devices, and other wireless transmitter operating in close proximity to the communication system. RFI can disrupt wireless signal and degrade communication system performance, sometimes more severe. Power line noises is also created by the electrical power distribution system. It can affect the wireless communication system, especially those operating in lower frequency bands. It can result from faulty power line equipment, transformer, or electrical discharge or arcing. Power line noise can coupled into nearby communication line or radiates electromagnetic source of energy, which causes interferences to the wireless system. Similarly, industrial machinery and equipment such as motor, generator, pumps, turbine can also generate electrical noise and vibration that interfere with the wireless communication. These sources are introduced unwanted signal into the environment, affect the quality of wireless signal, but their effects are localized. Similarly, transportation system, vehicles, aeroplanes, trains, and ships can also generate electromagnetic noise through their electrical systems, engine, and communication equipment. This noise can interfere with nearby wireless communication system, particularly in the close to the transport infrastructure. And sometimes human activities such as construction site, manufacturing plants, and crowded urban area can also introduce additional source of emissions. Internal source of noise in electronic system can arise from various component and process within the system itself. Here are some common internal source of noises. First, most important is intermodulation noise. When multiple signals of different frequencies passing through a non-linear devices, such as a power amplifier, so can make them produce additional unwanted signals at different frequencies and even times. Similarly, crosstalk in a multi-channel communication system, crosstalk can occur when signal from one channel interfere with the signal in the adjacent channel. Active device noise, active electronic devices such as transistor, amplifiers, and operational amplifiers generate some noise due to the random motion of the electron and hole within them. Similarly, passive components also generate noise such as resistor, capacitors, and inductors, and contribute to the internal noise to the wireless communication system. Insulator noise, insulator is an integral part of any wireless communication system, and particularly voltage control oscillators and the crystal oscillators generate noise due to the inherent noise source within the circuit itself. Switching noise, digital system that involves switching operations such as digital logic gates and flip-flop can generate some noise also. Power system noise, variation in the power supply voltage can introduce noise into the system and designing technique such as proper grounding and shielding and decoupling of the capacitor low noise component selection, and layout optimization. We can control the impact of internal noise sources. Additionally, signal conditional circuits, filtering, and noise reduction algorithms can be applied to improve the overall system performance. Thank you.